Hi, ladies and gentlemen. This is Mr. Green. This is my Class Connect for Geometry. I'm sorry I can't be with you today. I have to be out of the office and out of my house for the afternoon, so I apologize about that. But I wanted to give you this because what you're looking at this week is taking the Unit 5 test, and I want to make certain I give you a little review over Unit 5. So you'll have to excuse my voice. I'm fighting allergies right at the moment. So I'll continue to drink coffee, and that does make it get a little bit better. So here we go. Unit 5. You're going to be doing a review today. The test will open up tomorrow. You can take the Unit 5 test and get that out of the way. Now, I know you're concerned about, well, when's the final going to be? I will have a review that I will send you this week for the final. It'll be another recording. You can watch that review, and the final will open up this week. Okay? I'll probably open it up on Thursday for you guys. You'll have this week and next week to do that final. So don't worry about it. Don't panic. I will get in touch with you if you haven't got it done by Tuesday or Wednesday of next week, and we'll be working on trying to get that completed. Okay? All the other assignments for my class have to be turned in this week by Sunday. So you want to make certain you got everything else done other than the final, and you can take the final next week, and we'll be done with all the course. Okay? So here we go. Let's look at what we've got. For we're going to be looking at things like perimeter and area of triangles and quadrilaterals, circumference and area of circles, the Pythagorean theorem. We're going to look at some special right triangles and regular polygons. We're going to use the distance formula, and we're going to cover proofs in a coordinate geometry system. Okay, so let's look at this one here. First of all, it says a triangle has side lengths of 19, 27, and 12. What type of triangle is this? Well, according to the Pythagorean theorem, is if we said that the two smaller ones, the 12 squared plus the 19 squared, if that equals 27 squared, then we would know that we have a right triangle. But that Pythagorean theorem also told us that if there was an inequality in there, we could determine if it was a obtuse or a acute triangle. And so the first thing I did was I said 12 plus 19 is equal to 31. 31 is more than 27. So by the triangle hinge theorem we studied last unit, we know it is a triangle. Okay, so I take 12 squared plus 19 squared, I get 505, and 27 squared is 729. That 729 is so much greater than the 505. That tells me that it is an obtuse triangle. Whenever the c squared is the bigger one, it is an obtuse triangle. Okay? If the a squared plus b squared was the bigger one, then that would be an acute triangle. And that's the way you can use that information. Pythagorean theorem helping us to do that. Okay? Distance formula. What you have to do is you have to say you've got an x1, y1, and an x2, y2, and then plug it into the formula. So I'm going to say 10 minus 1 squared plus 1 minus 8 squared. Now, these are the x values here. Pointer. These are the x values here. These are the y values. You have to keep them separated like that. So 10 minus 1, that's 9. 1 minus 8, that's negative 7. You square 9, you get 81. You square negative 7, you get 49. 81 plus 49 is 130. Square root of 130 is approximately 20.7. So you could say square root of 130, or you could say 20.7. Either one of them would give you the correct answer there. If I'm looking at an object like this one, and I'm asked to find the area, first thing I like to do is I like to divide it up into shapes that I can actually determine what the size is, so that I can figure the area. Because this complex shape like this, I can't really figure the area of it. So I'm putting an imaginary line in here like that. And when I did that, I noticed that this has got this little marking all the way around, and it's the same as these two sides here. Well, if this one and this one and this one all add up to 15, that means each one of them must be 5. Why must they be 5? Well, because they're all equal, and I divided 3 in, I'm sorry, wrote a 3 there. I divided 3 into 15 and got 5. So that means each one of those sides is 5, right? Well, if this is a 5 by 5 squared, that means that one's got an area of 25. And this is a 5 by 5 squared here, that's got an area of 25. Well, if this one's 5, that must mean that this here is 5 also, because it was 10 all the way across. And 5 times 15 is 75. And when I add 75 and 25 and 25, I get 125. The other way you could do this is by subtracting. By subtracting, what do you mean? Well, if I notice that this is a 5 by 5 square here, this 25 that I wrote in red is being taken out of the 150, 10 by 15. So 150 minus 25 would give you that 125 also. And that's what I did over here in the text. Okay? So let's go forward and look at another one here. If I'm looking at the perimeter of something, the formula for perimeter is there's two 14s here. So I've got to add 14 twice, and I've got to add 24 twice. Right? Well, 14 twice is 28. 24 twice is 48. That gives me a total of 76 centimeters. Perimeter is the easy one. You're just adding up all the sides. Okay? If I'm looking at the area of a triangle, I have to remember my triangle formula. It's 1/2 base times height. My height in this case is 5. My base in this situation is 12. Does this little area here matter? No, because it's not inside the triangle. The only thing that matters is the length of the side of the triangle. Does this side over here of the triangle make a difference? Not at all, because it's at a slope. You only care about how high it is from the base up to the highest point, and that has to be at a 90-degree angle. So 5 times 12, that's 60, divided by 2, or 1/2 of that, is 30. That's where I got the 30 centimeters squared. Okay, trapezoid. You have to remember the formula for a trapezoid. It says B1 plus B2. There's B1, there's B2. I'm going to add 8 and 14 and get 22. I'm going to take half of that and get 11. And my height is right here, 6. So 11 times 6 gives me 66. And that would be my area of my trapezoid. Hexagons. Hexagons are a little bit harder because we don't really have a good formula for that. We've got this formula 1/2 AP, A being the apothem. I know, weird word, but that's what it is. And what I like to show in this situation is if I take this hexagon and I divide it up into triangles. See how that's divided up into triangles? How many triangles are there? Well, there are 6 triangles. 1, 2, 3, 4, 5, 6 triangles. Ooh. Each triangle has a base of 8. And 8 times 5 is 40, divided by 2 is 20. 20 times 6 gives me that 120. That is the area of the hexagon. I want to show you something. See how that 5 is the height of the triangle? It's also the apothem. This P, which is the perimeter of the hexagon, I've got 6 going around, 6 triangles, and each one of them has a base of 8. So 6 times 8, that's the perimeter, isn't it? 48. If you put all that together, you could see how we're using triangles to find the area of a hexagon. Okay? Circles. If you're looking at a circle like this and they're wanting the circumference, circumference is distance around the outside. 2 times pi times r. Well, r in this situation is 3 inches. They gave me that right here. AB is 3. So 3 times 2 is 6. That's 6 pi. Am I going to take it any further than that? No. Unless they tell me use 3.14 for pi in the particular question, I'm not going to go any further. I'm going to say it's 6 pi. Okay, I'm going to cough again, so hang on a second. Oh, dang. Okay, sorry I coughed in your ear. Didn't mean to do that. Okay, a little better. Didn't mean to cough in your ear. Apologize. Okay, this one it says if AC is 12, CB is 16, what is the length of AB? It's the Pythagorean theorem. A squared plus B squared will equal C squared. This side over here. So 12 squared plus 16 squared, 144 plus 256, that's 400. Take the square root of 400, I get 20. That's going to be the side over here, 20. I'm going to caution you on the Pythagorean theorem. I've had so many people who take the Pythagorean theorem and just routinely go a squared plus b squared equals c squared. They got two numbers. They try to square both of them and add it together to get the third number. Look at the triangle. It might not be drawn to scale, but it does represent the sides that you're looking at. So if they give you the longest side, you're not going to be adding them together. You're going to be subtracting. Okay? You want to make certain you know what you're looking at because it isn't always just taking the two numbers and adding, squaring them and adding them together. Okay? Okay. Here's a perfect example of that. Here they gave us AB, that's 34, and they give you AC, that's 16. In this situation, I would plug this in as the c squared and this one as the a squared. And then I can take the c squared, 34 squared, or 1156. Subtract the 256 from it and get that a squared is going to be equal to 900, or 30 centimeters. Now I want you to notice, not drawn to scale, but this side is definitely smaller than this side. Okay? And it's just a little bit of logic that you use in that situation. Longest side always has to be the biggest number. Okay? 30, 60, 90 triangle. Remember, we've got this ratio uh, x times the square root of 3 and 2x. So if they give me the length of the longest leg to be 10 square roots of 3, that's going to be this one. I'm going to say 10 square roots of 3 equals x times the square root of 3, divide the square root of 3 on both sides, x is going to be 10. So the shorter leg down here is going to be 10. No extra charge. The hypotenuse is going to be 20. Okay, for the part 2, one question you're going to have to explain why a hexagon is 1/2 AP, or 1/2 the apothem times the perimeter. And you're going to do the same thing that I did in this question up here, dividing it up into triangles. Show that the triangles, the 6 triangles times the base of each one of the triangles adds up to be that perimeter, and that the apothem and the height are the same number. That's all you've got to do to show that to work. You're going to have a distance formula problem, but it's going to be a cube. So what you have to do is, first of all, look at the cube and see if you can't find a triangle that you can solve. One of them will be one edge of the cube, one of them will be one side of a diagonal of the cube, and then you've got to find uh, the distance from this diagonal of one side and the edge of one side, and that will give you the diagonal of the cube. I'm not stating that very clearly, but if you think about a dice, it's going from opposite corner to opposite corner, and you're going to have to use the diagonal on one side and one edge of the cube to get to the diagonal length. Okay? So it's using the Pythagorean theorem twice to get there. And I think you guys can do it. Shouldn't be a problem. The coordinate proof, you're going to be asked to find out if you've got a parallelogram. Quick thing to think about. How do I prove something's a parallelogram? I prove it's a parallelogram by proving two opposite sides are parallel. Both pairs of opposite sides are parallel. How do you do that? Find their slope. For coordinate proof, the thing you have to do is pick your formula, use that formula, get values, show the values are the same, then you can say they're parallel, and you can say that those two sides are parallel. To get a parallelogram, you have to have two pairs of it. Okay? So, if you watch this recording, please send me a K-mail telling me the secret word for today is IEYE, and we will be in good shape, and I'll make certain you get credit for having attended the class. And I appreciate you telling me that you are in geometry at the top system, and I will talk to you next time we're together. Bye.